Hello everyone, I am Asha, Assistant Professor in Artificial Intelligence and Data Science. So welcome to this video series on data mining and data warehousing, where we will learn how large amount of data are stored, organized and converted into useful knowledge. This series is designed especially for ADS students with simple explanations, real-time examples and exam-oriented coverage. Let us start our journey of turning data into insights. KDD, Knowledge Discovery in Database. So KDD is a complete process of extracting knowledge from large database. So we have several stages. So first one is data selection. That means we have to choose relevant data. Second stage, data pre-processing. So we have to remove the noise and missing values. Third one, data transformation. Converts data into suitable format. And fourth one, data mining. Apply algorithms to extract patterns. And fifth one is interpretation or evaluation. Understand the result. So I can give you an example like identifying frequent subjects in which students fail using historical academic data. Understood? So I'll repeat. KDD is a complete process of converting data into useful knowledge. It includes steps like selection, pre-processing, transformation and data mining. So for your understanding, I can make it so simple. KDD is the overall framework and data mining is a part of KDD. CRISP-DM. It is a standard data mining model used in industry. It includes business understanding, data preparation, modeling, evaluation and deployment. So CRISP in the sense CR for cross and I for industry, S for standard, P for process. And DM is nothing but data mining. CRISP-DM. So CRISP-DM stands for what? Cross-industry standard process for data mining. It is one of the most widely used data mining models. So now we'll look into the phases of CRISP-DM. First one is business understanding. That means it will define the objectives. Second one, data understanding. It will collect and explore data. In this phase, we will collect and we will explore the data. Third phase, data preparation. We will clean and organize the data. Fourth phase, modeling. Here we will apply the mining technique or algorithm. Fifth one, evaluation. We will check the model accuracy. And last one, deployment. So we will use a model, that is a developed model in real life. So I can give you an example. Predicting student dropout rates. How can I predict student dropout rate? I need attendance and the performance data. Okay, so predicting student dropout rates using attendance and performance data. Next one is SEMMA model. SEMMA is a data mining methodology developed by SAS. So what are the SEMMA phases? First one is sample. So select data. Second one E for explore. Understand data patterns. Third one M for modify. Prepare data. And next phase is model. Apply algorithms. And the last phase is assess. Evaluate results. So S for sample, E for explore, M for modify, another M for model, and the last A is assess. Okay, so we are selecting the data, we are understanding the data pattern, then based on that we are preparing the data, and after preparing we are applying the algorithm, and finally we are evaluating the results. So I can give you an example. Analyzing customer data to predict whether they will buy a product or not. Next one is prediction performance measures. So prediction performance measures are used to check how well a model is performing. they compare predicted results with actual result. I can give you a real-time example. Comparing predicted student marks with actual exam marks. Why performance measures are needed? Performance measures helps us check whether a model is good or poor, compare different models and improve the model accuracy. Okay, so prediction performance measures are used to evaluate how well a prediction or classification model performs. Why performance measures are needed? Because to know whether the model is accurate and to compare the different models, and based on that we can improve the prediction quality. Accuracy shows how many predictions are correct. For example, if 90 out of 100 predictions are correct means accuracy is how much? 90%. Precision. Precision measures how many predicted positive results are actually correct. Example is, out of all students predicted as pass, how many actually passed? Regression measures calculate prediction error. They tell how far predicted values are from actual values. So used when output is numeric, that is like marks, salary, temperature. So here we have three. One is mean absolute error, MAE. Another one is MSE, mean squared error. And last one is root mean squared error, that is RMSE. So MAE means average of absolute errors between predicted and actual values. MSE means average of squared errors. Large errors are penalized more. And RMSE means square root of MSE. So easy to interpret. I can give you an example like predicting student marks using previous exam scores. I have taken one example. Here we have three students called A, B, C, and these students are predicting their marks like A may get 78, B may get 75 and C may get 85. But once after receiving their answer sheets, their actual marks were 80, 70 and 90 respectively. Now, how do we calculate the error? Error is nothing but the difference between predicted and actual. So, we will be getting the predicted value of A as, that is 80 minus 78, 2, and the error value of B is minus 5 and the error value of C is 5. But when you consider absolute value means what? We will remove the negative symbol, that is minus. So the absolute error value is 255. Now how many students are there? 3 students are there. So I have to calculate the average of the difference. So that means I have to add A plus B plus C divided by how many students? 3 students. So by 3. So 2 plus 5 plus 5. If you add, we will get 12. 12 by 3, that is nothing but 4. So what is the value of MAE here? It is 4. Next we have to calculate MSE. MSE is nothing but the average of actual minus predicted whole square. So what we got there? We got like 2, 5 and 5, right? So now we have to square it. So the square is nothing but 2 square is 4, 5 square is 25 and another 5 square is 25. So when you add all these and divide by 3 to find the average, the value will be 18. And finally we have to find RMSE, that is nothing but square root of MSE. So square root of MSE is nothing but 18. So we will be getting 4.24. So what did I say? Compared to all these three, MAE, MSE and RMSE, the preference is given for RMSE. Okay, that's all about the basic fundamentals of data mining. So data mining helps extract useful knowledge from data. Different types of mining handle different data formats. KDD, CRISP-DM and SEMMA define structured mining processes. Prediction performance measures evaluate the model accuracy. So these concepts form the foundation for advanced data mining techniques. So data mining is the backbone of AI and DS. It helps in understanding data, improving predictions, and building intelligent systems. Strong knowledge of data mining leads to better projects and career opportunities. Thanks for watching. We'll catch up in the next video.